Hello, welcome back to the fourth and final speedrun of today. We're going to be cleaning up our limits, and we're going to be talking about converging and diverging series. So sequences, sorry. Let's jump right in. So we've already met converging and diverging sequences in a sense, and it's, if you remember, the sum of an infinite sequence, which is an infinite geometric series, which is S of infinity really is equal to the first term over 1 minus the common ratio, with the common ratio, the absolute value being less than 1 and itself not being equal to 0. So if a geometric sequence had a common ratio less than 1 but greater than -1 and not equal to 0, it was a convergent series. Otherwise, we call the series divergent. In a more general sense, if we have some sequence where the limit as n tends to infinity of the nth term is equal to some number, like if we can actually resolve it, then we can say the sequence converges. Otherwise, we can say it diverges. So yeah, that's pretty much it. And so now we can jump into some questions. So I will be doing the odd ones. So the first one we need to find is determine whether this sequence converges or diverges. And it's 3, 1, 3, 1, 3, 1. So it's clear that this series doesn't converge because it's simply oscillating between two values. It's not approaching any one fixed value, and if we took the limit of the infinite term, we would not be able to resolve it. So this does not converge. Next, let's look at the sequence 1, 1/2, 1/3, 1/4, and so on. So by looking at the sequence, I think we can all tell that this sequence will converge because it's decreasing in value each time. The thing is, there's no common ratio between each term, but we can see that if we take the limit of the sequence as n approaches infinity of a to the n, this would equal 0. The graph of this would simply just tend to 0, something like that. So in this case, it would converge because all the values are approaching a number. So next, we need to determine whether the sequences converge, and if they do converge, state the number converges to. So the first sequence is the limit as n approaches infinity of n plus 2 over n. So again, we can evaluate this as equal to the limit as n approaches infinity of 1 plus 2 over n over 1. Dividing both top and bottom by n. And as n approaches infinity, this simply would approach 1. So indeed, this sequence would converge, and it would approach 1 in the process. Okay, on to the next one. We have the limit as n approaches infinity of n squared minus n over 2n squared plus the square root of n. So does the sequence converge or diverge? Well, if we divide both the top and bottom by n, we get the limit as n approaches 0 of, divide both the top and bottom by n squared. So we get 1 minus 1 over n over 2 plus n to the negative 1/2. So 2 effectively plus 1 over n, the square root of n. And as you can see, as this n tends to infinity, this sequence will simply tend to 1/2. So indeed, this sequence should converge to 1/2. Finally, let's look at the limit as n tends to infinity of 2n plus 2n squared plus 1 over 1 minus 2n cubed. Okay, so to determine the value of this, we want to divide both the top and bottom by 2 n cubed. So we get 2 over n plus 2 over n cubed over 1 minus 1 over n cubed minus 2, and this will simply tend to 0, or 0 over negative 2. So this should, yes, it would converge, and it would converge to 0. So that is that problem solved. So next, we need to determine whether this series converges, and if it converges, determine its sum. So the series is from n is equal to 0 to infinity in sigma form, negative 1 to the n, negative 1 to the n over 3 to the n. Well, this would simply be equal to negative 1 over 3 to the n. Oh, yeah. And so as n approaches infinity, well, actually, no, what we can do is we can divide both the top and bottom, so we get the top numerator as 1. So this will be equal to 1 over negative 3 to the n. And yeah, that looks pretty reasonable. Oh wait, no. Sorry, I'm being silly. So, because I forgot to put sigma notation here. So, this looks like n, from n is 0 to infinity, we need to find the sum of negative 1 over 3 to the n. And so, if we remember this is a geometric sequence with first term negative 1/3, and, first term is 1, and common ratio is negative 1/3. So, we can plug this into the sum, which is equal to the first term, 1, divided by 1 minus the common ratio, in this case, 4/3. So this sum should be equal to 3/4, and so yes, it should converge, and it should converge to the value of 3/4. Yeah, that's correct. Okay. On to the next one, we have the sum from n equals 0 to infinity of 2 over 10 to the power of n. And this does indeed look like it converges, but the question is to what? So, if we have 10 to the power of n, then, well, this will be equal to a geometric series with first term 2 and common ratio 1 over 10. So, this would be equal to 2 over 1 minus 1/10, which is equal to 20 over 9, I believe. So, yeah, that is correct. So this does converge, and it converges to the value of 20 over 9. Okay, on to the final one. And we have from n equal to 0 to infinity of e over pi to the n. And this does converge, technically. So this would be an infinite series with first value 1 and common ratio e over pi, so it's 1 minus e over pi. I guess if they want us to express it in a decimal form, well, what could we do here? We could multiply both top and bottom by pi. So this would, sorry, not decimal form, but simplify it. So it would be pi over pi minus e. And so this was what it would tend to. Yes, so yes, it would converge, and it would tend to this. Pi minus pi over e. Okay, next we have the final question, which is find the set of values for which n equals 0 to infinity of 3x over x plus 1 to the n converges. And so this is pretty simple. This will only converge if 3x over x plus 1, the absolute value of which is less than 1. So we have negative 1 is less than or equal to 3x over x plus 1, which is less than or equal to 1. So we need to find the set of values for which this is true. Of course, x not being equal to negative 1, since that would mean the denominator is 0. So first, x is not equal to negative 1. Then we have negative 1 is less than or equal to 3x over x plus 1 less than or equal to 1. So what can we get out of this? We can get out that negative x minus 1 is less than or equal to 3x, which is less than or equal to x plus 1. So if we subtract, actually it might be better to split these into two different inequalities. So we have negative x minus 1 is less than or equal to 3x, and 3x is less than or equal to x plus 1. So this top one would mean negative 1 is less than or equal to 4x. So x is greater than or equal to, x is greater than negative 1/4. And this one over here would mean that 3x over x plus 1, so we have 2x is less than, 1. So we have x is less than 1/2. So we have that negative 1/4 is less than x is less than 1/2, with, of course, x not being equal to negative 1, but that's really out of bounds already, so it should simply be these values that we've obtained. So yeah, it's simply negative 1/4 is less than or equal to x, which is less than or equal to 1/2. So yeah, that was it. That was all for the speedruns of today, and I hope you enjoyed it, and I hope to see you in the next one. Bye-bye.